You are welcome to another class in chemistry. Today we are looking into the topic criteria for purity. Most chemical substances, especially when they occur in nature, they are impure. And so to make them more useful, they are separated by the various techniques that we have earlier considered. But for a substance to be pure, there are certain criteria that we watch out for. The criteria are as follows. The purity of a substance can be determined by the following criteria. 1. Boiling point. 2. Melting point. 3. Density. 4. Specific gravity. A pure substance should have constant boiling point, melting point, density, and specific gravity. The boiling point of a substance is a criteria to determine the purity of a substance. All pure substances have fixed boiling points. But when the substance is impure, the boiling point increases. Thus, boiling point increases with impurity. All pure substances have fixed melting points. The melting point is the temperature in which a substance is converted from the solid state to the liquid state. When the substance is impure, the melting point decreases. Thus, there is a melting point depression. The presence of impurity decreases the melting point of a substance. Density and specific gravity. All pure substances have a fixed density and specific gravity, like melting and boiling points. These are criteria which enable us to determine whether a substance is pure or impure. Let us consider some illustrative examples. Example 1. What is the effect of impurities on the boiling point of a liquid? A. Does not affect boiling points. B. Increases boiling points. C. Decreases boiling points. D. Double the boiling points. Let's start from A. Does not affect boiling point. That is wrong. The presence of impurity enhances or increases boiling point. B. Increases boiling point. This is the correct option. The presence of impurity increases the cohesive forces between the particles of the liquid. C. Decreases boiling point. It is wrong. It increases boiling point. D. Double the boiling point. It is true that the boiling point increases, but not necessarily double. So the correct option is B. Example 2. People add antifreeze to their car radiators in cold regions to prevent the water from. The options are A. Boiling. Wrong. Antifreeze will not assist boiling, it will only assist freezing. B. Vaporization. Antifreeze will not favor vaporization of a liquid. Instead, it prevents it. C. Freezing. That is the correct option. An antifreeze helps to prevent the liquid from freezing. D. Condensing. Antifreeze do not help liquid to condense. They only help the liquid in the radiator to freeze. And so, the correct option is C. Example 3. A mixture of petrol and water can be separated through A. Boiling. Wrong. We don't separate mixture of water and petrol by boiling. Boiling can only be used to separate a mixture of a soluble solid in a liquid. B. Separating funnel. Yes. A separating funnel is used to separate a mixture of water and petrol because they are two immiscible liquids. C. Distillation. Wrong. Distillation is only used to separate a mixture of two miscible liquids whose boiling points are far apart. D. Fractional distillation. Wrong. Fractional distillation is used to separate a mixture of two liquids whose boiling points are very close to each other. Consequently, the correct answer is B. Example 4. Motorists sprinkle salt on icy roads to lower the 1. Boiling point of ice. Salt have nothing to do with the boiling point of ice, and so this is a wrong option. 2. Lower the melting point of ice. Yes, the salt help to lower the melting point of ice so as to lift water on the roads to make vehicles accessible. C. To make the road slippery. Obviously no. Putting salt on ice will not make the road to be slippery. Even when the road is slippery, it becomes dangerous to motorists. D. To make the roads unsafe for motorists. How can motorists want to make road unsafe for themselves? So the correct option is B. Lowering the melting point of ice so as to make the road accessible by motorists.